Today I will discuss Orifice and Venturimeter. Yeah, look at the board please. Orifice is an opening. Orifice is an opening for discharging liquid through this opening, and when the upper edge of the opening is below the water surface, this is called orifice, and it can be cut at the side wall or bottom wall. Yeah, and when this opening, upper edge of the opening is above the water surface, that means freely exposed to the atmosphere, it is called notch. And for discharging surplus quantity of water, this notch will be called weir, W-E-I-R. Yeah. So this is orifice. This is the difference between orifice, notch and weir. Yeah. Now this is the center line of orifice, and this is pressure head H. When liquid is discharging through the orifice, then first of all it is converging. Yeah, it is converging and reaching at the minimum section. This is CC, and this section is called vena contracta. Yeah, and generally if the dia of orifice is D, this section, that means vena contracta, here the distance, this is D by 2. Yeah, that means vena contracta at a distance D by 2 from the orifice. Yeah, and after vena contracta, this jet will be diverging or parallel. Yeah, this is called jet. Okay, all the dimension at vena contracta are actual, and all the dimension at orifice are theoretical. First of all, coefficient of contraction, C suffix C. It is the area of vena contracta, that means at CC, this is A suffix C, and area of orifice, this is A. Yeah, this ratio is called coefficient of contraction, and generally this value 0.62. Yeah, next, coefficient of velocity, C suffix V. It is the ratio of velocity at vena contracta, yeah, velocity of jet at vena contracta, and theoretical velocity of jet at orifice. Yeah, small v by capital V. Okay, and generally sub-edged orifice, this value is taken 0.98. Yeah, next, coefficient of discharge, C suffix D. It is the ratio of actual discharge at vena contracta by theoretical discharge at orifice. Yeah, and we know that discharge means area into velocity. So at vena contracta, this area is A suffix C and this velocity is small v. Yeah, and theoretical discharge, here this area small a and velocity, this is capital V. So this is A suffix C by A, that means coefficient of contraction, and small v by capital V, this is coefficient of velocity. That means coefficient of discharge equal to coefficient of contraction into coefficient of velocity. Yeah, this is about orifice. Now, Venturimeter. Yeah, Venturimeter is a device which measure discharge, that means a rate of flow through a pipe. Look at the board. This is pipe. This is pipe. This is center line, and here this is Venturimeter. Yeah, this is converging portion. This is throat. Yeah, and this is diverging portion. This is the diverging portion. Yeah, and here this is pipe. Okay, so this is pipe. Okay, now that means three part of Venturimeter. First of all, this is converging, this is throat, and this is diverging. Yeah, this is converging portion, this is short, and this is throat. The dia of throat is generally kept half the dia of pipe. Yeah, and this is diverging portion, this is long with respect to the converging portion. Yeah, now two section line, this is section 1 and this is section 2. Yeah, this is section 1 and this is section 2, and here a differential U-tube manometer is fitted. Differential U-tube manometer is fitted to measure the pressure difference between 1 and 2 section. When a liquid flow through this pipe, yeah, area of this section pipe A1 and velocity, this is V1. Here the throat area, this is A2 and velocity V2. When liquid is flowing through this pipe, then the liquid in the manometer, yeah, will be deflected. That means here this deflection, this is Y. Yeah, this is the construction of Venturimeter. Now we will deduce the value of actual discharge. Yeah, first of all, consider this Venturimeter as horizontal and there is no energy losses. Yeah, and applying Bernoulli's equation at 1 and 2 section. Yeah, this is first of all potential head, this is pressure head, and this is kinetic head at 1 section. That is equal to 2 section potential head, this is pressure head, and this is kinetic head. Yeah, and as the Venturimeter is horizontal, so potential head will be same. Yeah, that means Z1 equal to Z2. Yeah, so here this is V2 square by 2G minus V1 square by 2G, that is equal to P1 by omega minus P2 by omega, as Z1 equal to Z2. Yeah, and this pressure head difference between 1 and 2 section, this is called Venturi head. H is called Venturi head. Yeah, remember. So here V2 square minus V1 square, if you will get 2G as LCM, this is 2GH. Yeah, and this is number 1 equation. Now, applying discharge, we know that discharge Q, theoretical discharge Q equal to A1 V1, yeah, equal to A2 V2 at 1, 1 and 2, 2 section, yeah. According to continuity equation, we know that at all the section discharge is equal. Now, show here V2 equal to A1 V1 by A2, and putting this value in equation 1. Yeah, so here the value of V2 A1 V1 by A2 whole square minus V1 square, that is equal to 2GH. Yeah, simplify the equation. Yeah, here getting common, this is V1 square, and here A1 by A2 whole square minus 1, and this is 2GH. Yeah, so V1 square, that is A1 square minus A2 square by A2 square, this is equal to 2GH. So here V1 square, that is equal to A2 square by here the value, yeah, A1 square minus A2 square into 2GH. Yeah, so V1 equal to A2 by root A1 square minus A2 square into root 2GH. Yeah, the velocity at throat section, pipe section. Yeah, this is V1. So theoretical discharge, we know that A1 V1. So putting the value of V1 here, this is A1 A2 by root A1 square A2 square into 2GH. Yeah, this is theoretical discharge. This is theoretical discharge. So actual discharge, yeah, what is the value of actual discharge? We know that coefficient of discharge, this is equal to actual discharge by theoretical discharge. So actual discharge equal to coefficient of discharge into theoretical discharge. That means here putting the value of theoretical discharge, this is CD A1 A2 by A1 square minus A2 square into root 2GH. This is actual discharge, yeah, which is measured by the Venturimeter. Here H is Venturi head. Yeah, in this way we deduce the value of actual discharge. Okay, on the next day we will calculate the value of Venturi head in horizontal Venturimeter and inclined Venturimeter. Yeah, thank you.